Welcome back everyone. Hello, how are you? So today we are on our lecture 11th in our transition course. And today we are going, this is basically the last lecture for differentiation. I hope this is the last lecture for differentiation. Okay, so today we are going to cover the last part of the differentiation. Okay, so first of all, in the last class what we have done, okay, so those of you who are new here, okay, I have covered 2 lectures for differentiation, right? This is our 3rd lecture. So without further ado, let's start. So let's first do a quick revision of what we have done till now in differentiation, right? So first of all, what are the formulas that we know for differentiation? Okay, so first is for constant, no? So differentiation of constant, right? Differentiation of constant is equal to 0. Differentiation of constant is equal to 0. Because why? What is differentiation? Differentiation is rate of change. What is differentiation? Differentiation is rate of change of one variable with respect to another. Correct? So a constant does not change, so it will not change. Correct? Second is differentiation of, let's say if I have some linear function ax plus b, right, with respect to x, then the derivative of this function will be a. Okay, for ax it will become a and b is constant, so that is 0. For a power function, let's say I have a function with x power n. So differentiation of x power n with respect to x will give me n. What happens? The power comes forward and I will say n x power n minus 1. Okay, now let's move forward. Okay, then we have some let's say exponential function. So differentiation of a power x with respect to x, right? Differentiation of a power x with respect to x is a power x ln a, a power x ln a. Okay, now if I put, right, if I put a as e, so this will become e power x, correct? And what is differentiation of e power x? Differentiation of e power x is, let's substitute, so e power x ln e, right? And what is ln e? Ln e is 1. So differentiation of e power x is e power x. Second, differentiation of log function. So differentiation of log x base a. Differentiation of log x base a is 1 upon x ln a. 1 upon x ln a. And again, if I substitute a as e, then differentiation of ln x, right? And what is differentiation of ln x? 1 by x ln e. So what is ln e? 1. So 1 by x. So differentiation of ln x is 1 by x. Okay, then we have our trigonometric functions. So differentiation of sine x with respect to x is equal to cos x. Okay, differentiation of cos x with respect to x is equal to minus sine x. Okay, differentiation of tan x with respect to x is equal to minus 6 square x. Differentiation of cot x with respect to x is equal to minus cosec square x. Okay, differentiation of sec x is with respect to x is equal to sec x tan x, and finally differentiation of cosec x with respect to x is equal to minus cosec x cot x. Okay, so if you know all these formulas, okay, whatever formulas which we have written on this board, okay, if you know all these formulas, then right, you will not face any difficulty in your differentiation. Okay, clear? Let's move forward. So this is the question which I gave you for homework, right? So let's apply differentiation. Okay, so what is the differentiation? Dy by dt, right? Differentiation of y with respect to t is c. So what is the let's write this. Okay, differentiation with respect to t will be equal to 2t power 4 minus 10t square plus 13t, right? And there is a method for this, right? So what do I have? I have first function, right? This is function number 1, function number 2 and function number 3. I have 3 functions which are in addition. So if 3 functions are in addition, right, what can I do? I can apply this differentiation operator. What is this? This is known as differentiation operator. Okay, d by dt, let's write it here, that what is d by dt? D by dt is basically differentiation operator. Okay, what do you mean by operator? Operator is something which tells us what to do, right? For multiplication I will use a cross, no? For division I will use a division sign, this sign. So these are known as operators. So for differentiation, this is the operator. So let's apply this differentiation to each and every function, right? So if I have a function, right, 3 functions, let's say I have two or more functions which are in the sum or sum or subtraction part, right? So I can apply individually. So this will become d by dt, correct? And this will become 2t power 4, okay, minus I will have d by dt, right? And this will become 10t square, okay, plus d by dt, okay, d by dt, and this will become 13t. Okay, so let's apply. Now what is this? This is some constant 2. So this constant 2 can come out of integration 2, right? Sorry, differentiation. And what is differentiation? I will be left with differentiation of t power 4 upon dt. Differentiation of t power 4 upon dt. Minus, again what do I have? A 10 here. So this 10 can come out of differentiation because it is a constant. So I will have differentiation of t square upon dt. And finally I have 13, which is also a constant. So pull this 13 out of the differentiation and I have d by dt. Correct? So let's solve. What do I have finally? So finally, if I look here, right, this 2 I can write as it is, and differentiation of t power 4. So if I have t power 4, right, what formula can I use? I can use the power formula, right? So differentiation of, just substitute x as t. So this will become t and this will also become t, right? So this will become n t power n minus 1. So what is the way to do? This 4 will come forward, right? And I will say t power 4 minus 1. Okay, minus, just 1 minute, let's remove this. Okay, minus 10 into this 2 will jump forward, right? And I will write t and 2 minus 1 plus 13, and differentiation of t with respect to t is 1, right? So finally I have 1. So what do I have as the final answer? Finally I have 8t power 3 minus 20t, right, plus 13. This is my final answer. Clear? I hope you don't have any doubts, okay? And if you have any doubts, please write in the comment section so that I can clear them. One more question I gave you for homework. Let's try to solve this also, right? So differentiation of r with respect to z, right? Now what is this? This z is my variable, no? Variable, input variable can be anything, right? It is not necessary that it should be t or it should be x, okay? It can vary. So this will become, so let's write it in a proper way so that we can differentiate it very nicely, right? So let's write this function. This will become r, input, this will become z, right? And what can I write this as? I can write z power, right, minus 3 by 2, z power minus 3 by 2 plus, right, 1 by 8, and this will become z power minus 4, correct, minus 1 by 3 into z power minus 10. Okay, so now let's differentiate. So dr by dz is equal to 6, right? This minus 3 by 2 will jump forward, minus 3 by 2 will jump forward, and what I'll do, I will subtract from this z, right? I have this z, so I'm writing z as this, right? What will happen? In this z, I will subtract minus 1, so 3 by 2 minus 1, correct? Plus, I will have 1 by 8, yes, and this minus 4 will jump forward, minus 4 will jump forward, and I can subtract minus 1 from this 4, so minus 4, minus 1. And finally, what do I have? Minus 1, right? Minus 1 by 3. This minus 10 will jump forward, minus 10, and I will subtract minus 1 from this. So minus 10, minus 1. Okay, so what do I have here? I have this, right? So this will become 2 and 3s are. So this will become minus 9, right? Minus 9, z power. Now what is this? This will become minus 5 by 2, minus 5 by 2. Okay, and what is this? 4 1s are 4, 4 2s are 8. So this will become minus 1 by 2, minus 1 by 2, z power minus 5, z power minus 5, and this will become minus minus plus, so this will become plus 10 by 3, plus 10 by 3, z power minus 11, z power minus 11. Okay, so what is the final answer I can write? So the final answer I can write is, okay, so this will become dr by dz, right, dr by dz is equal to minus 9 upon z power, this will become 5 by 2, 5 by 2, and this will become minus 1 by 2 into z power 5, and finally I have plus 10 by 3 into z power 11, right? So this is my final answer here. Okay, so this is very easy. Okay, this question looks very difficult, but right, it is not. Okay, calculation part you have to try. Okay, calculation sometimes can be difficult, but it is okay, you should try. Okay, it looks very messy, that okay, and kind of lengthy, but you have to try them. Okay, and once you love doing calculations, no, okay, what will happen, physics will become very easy for you. Eventually what happens, that students are afraid of calculation. Okay, they think that okay, I'm doing something wrong. Okay, when you come here, you will be like, there will be something in your mind that okay, now I'm not doing it correct, I have made a mistake, and something like that. Okay, so don't have a doubt, try to take the answer to the end, and if you don't get the answer right, what you can do, just cut this off and try again. Yes or no? Okay, so but don't be afraid of solving questions, don't be afraid of trying, attempting. Okay, that is the most important part an aspirant should do. Okay, that is attempting questions. Next part, so this question I have, right, and it is given that fx is equal to e power x into sin x into cos x, right? So what is the hint I gave you in the last class? If you go back, right, I gave you a hint that how many functions I have. I have function 1, this is my second function, and this is my third function. I have 3 functions, right? But I cannot solve 3 functions, no, in multiplication, right? What do I have to do? I have to make 3 functions, okay, 3 functions to 2 functions. Why 3 functions to 2 functions? So that I can apply product rule. Okay, this is my main motto. Okay, you should know what you are doing basically. So we have 3 functions, but 3 functions I cannot solve. Okay, if I have 2 functions, I can easily apply the product rule. Okay, so this is where trigonometry will come in play. Okay, we have done trigonometric formulas. So if you think, right, what can I do? I can write sine x into cos x, right? If I have sine x into cos x, okay, I will multiply and divide by 2, right? Multiply and divide by 2, what will happen? It will remain same, no? Because 2 into 2, this will cancel 1, right? Now, what is this? What is 2 sine x cos x? 2 sine x cos x is sine 2x, right, by 2. So basically what can I do? I can write this, okay, I can write sine x cos x as this function, right? So finally my fx will become, right, fx will become e power x into sine 2x by 2, sine 2x by 2. So this is my function fx. Okay, so once I have this function fx, right, I can, so what will happen now? I have 2 functions, no? What is this? This is my function number 1, right, and this is my function number 2, right? I have 2 functions fx and gx. This is my fx. Let's name something else because fx already is there. So I have 2 functions, and what are the name of the functions? Okay, gx and hx. Let's say gx and hx are my 2 functions which I have. And what can I do here? I will apply my product rule here. And what is the product rule? Product rule says that if I have 2 functions, okay, fx is equal to gx into hx, right? What I can do? I can apply the product rule individually. So differentiation of f with respect to x is, right, first differentiation g function and keep h as it is, plus now I will keep the g function as it is and differentiate the other function. Okay, clear? So now we will do the same thing here, right? So differentiation of fx with respect to x is equal to, right, I will differentiate my first function. What is my first function? E power x with respect to x, and I will keep my second function as it is, that is sine 2x, plus now what I will do, I will keep my first function as it is and I will differentiate my second function, right? So now what is differentiation of e power x? What is differentiation of e power x? Differentiation of e power x with respect to x is e power x, and I will keep this sine 2x as it is, plus Now this e power x is this, and what is differentiation of sine 2x, right? So differentiation of sine 2x, okay? So sine 2x is how much? Cos 2x. But now there is a problem, okay? Is this complete? No, right? What about this 2x, okay? So there we should know that I cannot differentiate this cos 2. I have to differentiate, because see, I know that differentiation of, okay, what is the problem I am facing here? That I know that differentiation of, okay, what is the problem? Okay, let's write the problem here. The problem here is that I know that differentiation of cos x, so differentiation of sin x or differentiation of sin x is equals to cos x. But is differentiation of sin 2x equals to cos 2x? Is this correct? So let me tell you, this is not correct, okay? This is correct, but this is not correct. We know the formula for differentiation of sin x, but not sin 2x, okay? So I cannot solve this question further, okay? I cannot solve this question further, okay? So now how to solve these type of questions, okay? So now we will talk about that later on, but let's first move on to the different question, okay? Division rule, okay? We have a breaker here. I'll come back to this part, okay? We have a breaker here and we'll come back to this part, but let's move forward here, okay? So division rule, what does division rule say? That if I have two functions, okay, if I have two functions, fx is given as gx upon hx, okay, what do I have? I have two functions which are in division, okay? So two functions in division, okay? When two functions are in division, then I will use this formula, okay? And let's understand this, okay? So what is this? Basically, can I say this is my numerator and this is my denominator, okay? So now let's understand how to remember this, okay? So let's understand that if, okay, let's suppose if you are going to a clinic, right? I go to a clinic. So who is the first person you meet? Okay, I will meet the nurse, right? When I go to a clinic, the first person I will meet is the nurse, okay? So first of all, how to solve this? That differentiation of f with respect to x is, so whom am I meeting first? When I just walk inside the clinic, right, the first person I will meet is the nurse. So basically I am differentiating the nurse. And what is the nurse? Gx, numerator, right? I differentiate. And what about the doctor? I will keep the doctor as it is, correct? Minus. Now once I meet the nurse, right, the nurse will send me to the doctor, no? Right? So now I will differentiate the doctor and I will keep the nurse as it is, right? So what is nurse? Nurse is the numerator. And now what is doctor? Doctor is the denominator. So I will differentiate the doctor. Okay, and finally who will take the money? Finally who will take the money? The doctor will take the money, no? So I will say hx square, okay? So this is a way to remember that. How to remember this? That understand that, let's suppose I walk into a clinic, right? Who is the first person I'll meet? The first person that I'll meet is the nurse, right? So nurse is numerator, so I'll differentiate the numerator and I'll keep the denominator or the doctor as it is, minus, right? Then the nurse will send me to the doctor, right? So now the nurse will sit and doctor will look to me, right? So the nurse or the numerator you keep as it is and the doctor will look at me, or basically will differentiate the denominator. And finally who will take the money? The doctor will take the money, right? So doctor square or the denominator square. Okay, this is just a way to remember. Okay, you can use your own methods, but this is how I remembered and I do not forget this. Clear? Okay, so we will use the division formula to solve some questions. Let's look into this. So let's suppose if I have two functions here, okay, if I have two functions, and what are the two functions? So this is my numerator and this is my denominator, right? So let's try so differentiation of gx with respect to x is equal to, okay, let's solve this together. Okay, so what did I tell you? When I go to the go to a clinic, right? Whom I meet first? I'll meet the nurse. So differentiate the nurse. So differentiation of nurse. Okay, I will differentiate the nurse. Okay, now what about the doctor? Doctor will sit as it is, minus. Now, then the nurse will send me to the doctor, right? So I will keep the nurse as it is, and now since I am going to the doctor, doctor will look into me, so differentiation of the doctor part, correct? And finally who will take the money? The money will be taken by the doctor. So 2 minus x whole square. Okay, so let's differentiate this, right? So what do I have? 6x square. What is 6x square? 12x, right? This 2 will come forward, this will become 6 2s are 12, and x 2 minus 1 will become 1. And 2 minus x I will write as it is, 2 minus x I will write as it is, minus. Now what is this? 6x square, 6x square as it is. Okay, and what is this? Okay, what is this? This is 2 minus x. Differentiation of 2 minus x is, what is differentiation of 2? 2 is 0, right? And what is minus x differentiation? Minus 1. Okay, and finally what do I have? 2 minus x whole square. 2 minus x whole square. Okay, so what is the final answer I will have? So the final answer, if you look here, this will become 12x into 2 minus x, right? And finally what do I have? Minus 6x, right? This minus and this will become minus, so minus minus become plus, whereas 6x square, right, upon I have 2 minus x whole square, 2 minus x whole square, and you can simplify this. Okay, so this is the way you should apply your division rule. Okay, what is the most important thing? Most important thing is you should know how to write this first part. If you know this first step, this is the calculation, basic calculation which you can do. But this step which we are looking here, okay, this application of division rule, okay, or the nurse doctor rule is very important, that how you apply this. Okay, if you have any doubt, I'll repeat again that first of all you look at the numerator, you differentiate the numerator, you keep the denominator as it is, minus, then you keep the numerator as it is and you differentiate the denominator upon denominator square. Okay, upon denominator square. Okay, clear? So this is the way you can remember this. Okay, I have one more question. Find the differentiation, find the derivative of tan x is equal to sin x upon cos x, right? So what is tan x? Tan x is given as sin x upon cos x, right? This is the function given to me. Okay, what is this? This is a function given to me. Okay, so I will write fx is equal to sin x upon cos x, and what do I have? I have two functions, right? This is my function numerator and this is my denominator, right? I have two functions, numerator and denominator. So what is the formula? The formula is, right, differentiation of tan x. Differentiation of tan x is, first you differentiate the numerator, correct, and you keep the denominator as it is, minus, then you keep the numerator as it is, right, okay, you keep the numerator as it is and you differentiate the denominator. And what is the denominator? Differentiation of cos x with respect to x upon finally, right, denominator square. What is denominator? Cos x square, right? So what do I have here? I have, what is differentiation of sin x? Differentiation of sin x is cos x, right, and this cos x as it is, minus, now what is this? Sin x, I'll write sin x as it is, and what is differentiation of cos x? Differentiation of cos x is minus sin x, so minus sin x upon cos x square. So cos square x, okay, I can write cos x into cos x. Cos x into cos x is cos square x. Okay, so what is this now? So cos square x, and what is this? Sin x into minus sin x. So this will become how much? Sin x into sin x minus sin square x, and this will become plus sin square x upon cos square x. And what is sin square x plus cos square x? 1, right? So this will become 1 upon cos square x, and 1 upon cos square x is basically how much? 6 square x, right? 1 upon sec square x. Okay, so this is my final answer. So basically we are saying that differentiation of tan x is sec square x, right? And we already know the formula here. Look, we already know the formula, that differentiation of tan x. What is tan x? Tan x is sec square x. Yes or no? So we have proved this formula. Okay, so these are some formulas which you should know. Okay, these are the very important formulas. You should know each and every formula which is written on this board. Yeah. Okay, and there are various methods, okay, which we have talked about. So we have talked about product rule, division rule. These are the most two important formulas. Okay, and with this we'll move on to a more important topic, that is chain rule. Okay, so why this chain rule is important? Okay, why this chain rule is important, let's understand. Okay, so when you were solving this question, no, right, what did I tell you? That we have like, and there is a dead end here. What is a dead end? That differentiation of cos 2x, differentiation of sin x is cos x. What about differentiation of sin 2x? Is this cos 2x? No, right? There is a problem here. Okay, so we are here to address this problem, that what if we are stuck in some similar situation, how to deal with this. So there is a rule known as chain rule, okay, and that will help here. Okay, so what is given? That I have a function inside a function, right? What is this? I have first function gx, and this gx is inside fx, right? How many functions I have? Two functions. So in that scenario, what do? Right, we start from outside. Okay, so we start from outside, and go inside, right? So how to understand this? Okay, so let's understand. Okay, whatever is written on this board, just forget about that. Okay, what we are trying to do is, let's understand here, that just 1 minute, that if this is the house, okay, if this is a house which I have, okay, okay, and this is a very big house which we have, correct? And there are many doors here, okay, one door, second door, third door, fourth door, okay, and finally I want to come inside this room. Okay, this is the last room, right? So how will you come inside this room if I want to come, right? I will first, this person will enter this door. Yes or no? This person will enter this door, and then it will, from this door it will go to this door, then from here it will go here, and it will go here. No? Yes or no? Can I come directly jump from this door to this door? No, right? I have to go from each door, no, one step at a time. Right? And what is the way I'm going? I'm going from outside to inside. Okay, if you understand this thing, okay, if you understand this thing, you understand the chain rule. That what we are trying to do, we are basically, my main is that I want to reach here. Okay, I want to reach here. How can I reach here? That if I go from outside to inside, one step at a time. I cannot jump. Okay, if I jump, I will not be able to reach there. Okay, don't use your brain that, okay sir, what if we jump from the roof? Okay, not allowed here. Clear? So this is the chain rule which we are going to use here. That what do I have? I have, see, this is the inside function. We have to reach here, right? This is my outside function. This is my gx. This is my first door. This is my second door, and I have to reach here finally. Okay, so what is the method? So let's try to solve this question, right? Cos 2x. So let's say if I have a function cos 2x, right? What is my function? My function is cos 2x. So what is the most outside function you can see? What is the first function you can see? What is the thing? I have to go from outside to inside. Okay, remember. So what is the function you can see outside, right? So if you look, right, I can see cos x, cos. Forget about 2x. I can see cos. Yes or no? So what is differentiation of cos x, right? So differentiation of fx we are doing, right? So what is differentiation of cos? Right? I know differentiation of cos is minus sine. So I'll write minus sine. So what about inside? You will write inside function as it is. So minus sine 2x. Okay, what we have done? We have first taken the outside function, right, and we have differentiated that. So cos x is minus sine x, and inside we'll write as it is into. Now second step is, what is the second function you can see? So if you go inside, right, if you go inside, I can say that this 2x is my second function. Yes or no? This 2x is my second function. So what is the differentiation of 2x? So differentiation of 2x is 2. Right? And is there any function inside 2x? No. Correct? I have reached the most inner part. So this is my final answer. Simple as that. Okay. So let's try to solve one more question. What if I have a question, okay, and it is given that fx is equal to sine 2x. What is the differentiation? So differentiation of fx, right, with respect to x is, now differentiation of sine 2x. So what is the outermost function? Outermost function is sine. So I will differentiate this sine. And what do I get? Sine is cos. So I will get cos 2x. Right? And what inside function is 2x. So differentiation of 2x is 2. This is my final answer. Clear? Let's solve one more question. Okay. Let's say if I have a function fx is equal to e power x square. E power x square. Okay. So what is the first function I can see? The first function I can see is e. No? E is a function. Right? So e, so what is differentiation of ex? So differentiation of e is basically e only, no? So I will say e, and what about this x square? I will write this x square as it is. Now what is the second function I can see? The second function I can see is x square. So what is the differentiation of x square? Differentiation of x square is 2x. Right? And then I will reach to x, right? So now I have reached the innermost function. So this is my final answer. Clear? Okay. So let's solve one more question. What do I have? Y equals to sine 2x whole square. What is the function? My fx is sine 2x into whole square. Okay. So now what is the first function you can see? So the first function you should answer is my square function here. What is this? The square function is my first function. So first function I will differentiate is the square function. So I will say differentiation of fx with respect to x is, what happens? This 2 comes forward. This is the power rule I am applying. So this 2 will come forward and I will have sine 2x. Okay. 2 minus 1 will become 1. Right? 2 minus 1 will become 1 into. Now what is the function I will see inside? After I finish this power function, I will go inside and what do I see? I see sine 2x. Right? So what is differentiation of sine? Sine is cos. So I will say cos into 2x. Yes or no? And once I finish this cos, what is the inside function? I have 2x. Right? And what is the differentiation of 2x? Differentiation of 2x is 2. Right? So what has happened? I have, right, successfully went from the outside function to the innermost function. So let's repeat that the outside function was the square function, then the second function was the sine function, right? So first differentiate the square function, first part over, right? I'll keep what is inside as it is, untouched. Then what is the second function? Sine function. So for sine it is cos 2x. What is inside? 2x, which will remain as it is. And finally differentiation of 2x is 2, right? So this is the way you should apply chain rule. Okay, let's solve one more question. Okay, what do I have? I have calculate the derivative of fx is equal to this function. Okay, so what do I have? Fx is equal to, right, root of ln 2x square plus 1. Right? So what can I write this as? I can write ln 2x square plus 1, right, power 1 by 2, power 1 by 2. Yes or no? So what is the outermost function you can see? What is the outermost function you can see? So for me, the outermost function is this power function, right, 1 by 2. So I will take this 1 by 2 in front and I will keep what is inside as it is. Ln 2x square plus 1, right, and this will become how much? 1 by 2 minus 1, 1 by 2 minus 1 into. into then what is the second function I can see? This ln function, no? Ln function. So what is differentiation of ln? Ln is 1 upon x, right? So 1, and this is treated as x, so this will become 1 by 2x square plus 1, correct? After ln, what is the second function, third function I can see? This function, no? 2x square plus 1. So again multiplication sign, and I will solve this function. So what is this? Differentiation of 2x square is how much? This 2 will come front, right? And 2 minus 1 will be 1. So this will become 4 into x. And finally differentiation of 1 is 0. Differentiation of 1 is 0. Okay, so this is my final answer which I have here. Okay, clear? So this is how you apply the, and you can further simplify this. Okay, this can be simplified, but this I am teaching you the chain rule, that how you should apply chain rule. Okay, if you have any doubts, please ask me. Okay, so we have done many questions here. Okay, we have done many examples, right? And this is what basically chain rule is. Okay, I'll repeat that you understand that I have to go from each door one step at a time. Okay, basically I can say what is the door? One function. Okay, so basically I can say I have to go through each function one step at a time. Okay, function one step at a time. Okay, that is from outside function to inside function. Okay, clear? So let's move forward. Okay, so now once we finish this, right, find the slope of a function at any point. No, so basically let's suppose that what is the use of differentiation. Okay, we have now done differentiation, right? We have found differentiation for different functions, right? So if I want to say what we have done till now, that first of all I learned that what differentiation means. Differentiation means basically finding the slope at a particular point. Simple as that. Because for a straight line I can calculate the slope, yes or no? But for a function, right, for a curve function like this, basically what we are doing, that I am taking 2 points, point number 1 and point number 2, right? If I join this straight line, right, if I join these 2 points using a straight line, yes, I can find the slope for this straight line. But now if I keep changing this point, no, the slope will keep on changing. But what if I say that I want to find the slope at this particular point? If I want to find the slope at this particular point, right, then basically what we are doing, we are taking these 2 points very close to each other. So I will bring this point 1 at this point, and I will bring this 2 point at this point, right? And finally when these 2 points, right, are very close to each other, okay, we can basically find the slope at the particular point. Okay, so let's write this, that, okay, I have discussed this in the first lecture. Okay, that what does differentiation means. Okay, so I'll write again. Differentiation means calculating slope of tangent to a point. Differentiation means calculating slope of tangent at a particular point of a curve. Simple as that. Okay, that I am trying to find the slope of this straight line or slope of this tangent at this particular point for this curve. Okay, so now let's solve this question. What is given? That determine the slope of the curve. Yes, this curve is given to me, and at which point I want to find? I want to find the slope at this point. Okay, find slope at this point, right, for this curve. Okay, for this curve. This is the simple meaning of this question. Okay, so for this curve I want to find the slope at this particular point. Okay, so let's say this is my curve. Okay, and this point P, okay, given in the question, okay, that is what 2 comma minus 15 is given. I want to basically find the slope for this tangent, right, at this particular point. So how will you do this? I will differentiate this function, right? So first differentiate. So I will say dy by dx, right? Dy by dx, or basically this is delta y by delta x. But when, okay, when the, what we say that this x is very small, okay, when this change is very small, because you look here, no, these 2 points are very close to each other. So when the change is very small, this delta will become dx, okay, delta y will become dy, clear? So now what can I say? Dy by dx, right? Dy by dx, okay. So see, someone is asking that for JEE, no, see, this is for JEE and NEET both, because see, the basics of maths, right? Basic mathematics. What is the name of this chapter? Basic maths, okay. We have started with basic mathematics, right? We have covered topics like, okay, what are the topics that we have covered? The topics that we have covered are functions, straight line, quadratic equations, trigonometry, and now differentiation, and later on integration, okay. And these topics are useful for both JEE and NEET, because otherwise if you don't know these topics, you cannot learn physics, okay. This is very, very important, okay. So anyone can learn this, okay, JEE and NEET students both. So we are basically trying to find the slope at this particular point, and the meaning of slope is differentiation. So let's differentiate, right? So what do I have? I can say differentiation of, what is the curve? X cube, right, minus x square plus 1, okay, upon dx. So what do I have here, right? Differentiation of x cube is how much? 3x square, right, minus differentiation of x square is 2x plus 1 is 0, okay. So this is my differentiation, okay. But now see here, what I'll do for this particular point, no, okay, see, I can also find the slope here, I can also find the slope here, no, but for which particular point? I want to find the slope at this particular point. So I have to tell the question, no, that okay, this is the point where I want to find the slope, right? And how will you be able to do this? By substituting the given value or the condition, okay. So I will substitute inside, and what are the values? 2 comma minus 15, okay. Now what is the input that it takes, okay, what is the input it takes, okay. So basically this means slope, okay, this means slope, and slope is equal to, so x is the input which can take, no. So I will substitute the values of x. So this will become 3 into 2 square minus 2 into 2, right. So this will become how much? This will become 3 into 4. So 3 4s are 12 minus this will become 4. So how much is this? This is 8, right. So the value of slope at this particular point, 2 comma minus 15, is how much? For this particular curve is 8, okay, clear? So this types of questions are asked in the exam, okay, and later on you'll understand, okay, that when we see, right now we are dealing in terms of y and x, right, but I can also write here x, I can also write here as some position or some velocity, okay. I can also write here time. Let's suppose if I write velocity here, okay, if I just simply, just instead of y, I write v, that is velocity, and if I write this as time, right, let's suppose if I change this, okay. So basically now what will I ask? I will find that what is dv by dt? It is acceleration, okay. So this slope is basically giving me acceleration, okay. So basically what type of question I can ask? I can ask that at t equals to 2, find acceleration, right. I will get the same answer, for this question, because dv by dt, that is rate of change of velocity with respect to time. What is this? dv by dt, rate of change of velocity with respect to time, is basically acceleration, and basically I am finding the acceleration, okay. So acceleration at t equals to 2. What is t equals to 2? Basically x equals to 2 is 8. You understand? See, so this is where the physics and maths will meet, okay. This is where the physics and maths will meet. But now you forget about this velocity and acceleration, okay. What I need you to do is, you should understand this maths part very nicely here, okay. And if you are able to do this part very nicely, okay, later on what will happen, that when you start learning physics, no, physics is very easy, simple as that, okay. What is physics? Physics is the observations that you make, okay. You know that if I kick a football, it will go forward, no, but if a football is coming to me and I stop with my leg, it will stop. Okay, so that are observations that I make. You know that the planets revolve around the sun. But now if you want to tell me, what you will do, you'll use maths. Okay, so that is why maths is very important in physics. Okay, clear? So I hope you understand this part. Okay, I have one more question here. This is a homework question I will give you. Okay, you try to find the slope of the curve. Now I have not given any particular point. Okay, you take any point if you want to. Okay, let's say the point if I want to find is, let's say 1, 1. Okay, and second point P is 1, 1, and Q is, let's say, if I want to minus 1, 1. Okay, these are the 2 points at P and Q. Okay, please try to find it here. Okay, so now in the next class we will start with the concept of maxima and minima. Okay, that for a curve at which particular point you will get the maximum value. Okay, you will get the minimum value, and this all can be done using the help of differentiation, concepts of differentiation. Okay, so we will end the class now because I am short of time, and let's meet on Monday, okay, with a new session. And there are few questions which are left. We will do them in the next class. Okay, in the next class also I will start with integration part. So if you have any doubts regarding this lecture or any other doubt, please scan this QR code. Okay, a Google form will pop up, and also please join our Telegram channel, right? And okay, thank you. And have a nice day. Thank you, everyone.